In this video, we will talk about how to factor using a graph. So let's read the directions and then let's answer, okay? If you need any extra space, use notebook paper for taking notes. Factor the following polynomial functions by analyzing the graph of the function to help you find linear factors based on the zeros of the function. Do you understand that? It's written in English. Do you get it? No? And then let's read one more time, okay? Factor the following polynomial functions. So you have function here. We need to factor it out, okay? By analyzing the graph. Analyzing. What do they mean? So we'll look at the graph and we will find some zeros of the function. Do you remember the synonym of the zeros? Roots. That's right. From the graph, x-intercepts, right? That's right. So we will look at x-intercepts and then we will talk about factoring, okay? So we'll use the graph to find the factors of third power, fourth power, like that, okay? In this video, I will stop at number 12 and then I'll create the next video tomorrow, okay? All right, so let's think about doing that and let's find linear factors and I'll talk about those soon also. Number 9, so let's look at the graph and think about what we did in quadratics, okay? We talk about standard form, also at the same time we talk about intercepts form, so we use those roots of the functions. So can you tell me what are the roots here?
-1, 1, and 2.
Right here, right here, right there. X-intercepts are the roots or zeros of the function. So that is -1 and 1 and 2, right? And my answer is going to be like that. That is the name of the function. I will use the same name of the function, f of x. And I need to have factored form. That's going to be called factor, right? So let's make connections. From the first root, can you tell me a factor? X plus 1, correct. If you put -1 in this factor, -1 plus 1 makes number 0, right? So that's right. If you make one factor 0, that will be a factor, and which is called a 0 of the solutions, okay? All right, from the second root, number 1, can you give me a factor? X minus 1. So you plug number 1 in the factor, you will make number 0, right? Third one, number 2, give me a factor. X minus 2. That's right. That's it. That's how we factor this cubic function by using the graph. It's easy looking, isn't it? Okay, but problem gets harder by the number, and I'll add more stuff. Can you try on your own first, and then I'll add some more lessons, okay? All right, let me pause at this point, and you try number 10, 11, 12 briefly, and then I'll continue to talk about those. All right, question number 10. Before we move on to number 10, let's talk about one little thing, okay? What is the degree of the polynomial function f in number 9? Degree 3. How many solutions do we have? 3 solutions, right? 3 roots. Oh, same numbers, right? So in the future, we will talk about a theorem based on the number of the solutions and number of the degree, okay? All right, next question, number 10. Did you find any solutions from x-intercepts? 2 solutions, okay. How many solutions do you expect? 3. Why? Because degree is 3 and we expect 3 solutions, but we found 0 and 2, right? So 0, if the graph is passing through the x-axis, we have multiplicity 1, okay? If the graph is passing through like that, degree, the multiplicity 1. If the graph is does not passing through, it turns like that, and we have multiplicity 2, something like this. The graph is going down and touch the x-axis and turn around rapidly, and at that point we have a solution, but it has multiplicity 2. It means double root. Does it look like parabola shape? Yep, and we say it's a double root. So I can say, all right, here, because the graph is turning around at x-axis, number 2, roots number 2 has multiplicity 2. In other words, I can say, what are the solutions? 0, 2, 2. I can repeat the same number twice, okay? So that is the one thing we need to remember from the graph, and we will talk about those more later, okay? So from the first one, 0, what is the factor? You can say x plus 0 or x minus 0, but simplest form will be x itself, right? Okay. From the number 2, what is the factor? X minus 2. And by just checking this solution so far, the factors, when I expand this, what is the degree of this? This will be only degree 2, right? It doesn't match with the given problem, so I need to raise the power at the solution 2. So x minus 2 should be repeated twice, so we are raising the power. So that power gives us the multiplicity 2. Does it make sense? All right, so it is showing like that. When we see turning around on the x-axis, there is a multiplicity 2. Okay, so that is it. How do I check this is factored correctly or not? I can expand, right, to perfect square and then distributive property, multiply, expand, and we can check this is same as given problem. Okay? Any questions so far? All right. From now on, you need to use notebook paper, okay? So I'm going to switch the notes, and let me do number 11 in the bigger space, okay? If you can write smaller, you can write smaller. That's fine. Number 11. What numbers do you see? What is the exact number? 1, right? I see root 1. And would you like to say this 2 point what? 5. Can I say 2.45? Can I say this as 2.4555? We are not sure what it is, right? So we are not going to use any decimal or any guessing numbers, okay? If it is at the corner of the grid, we'll use an integer as a solution, but we'll figure it out soon, okay? So m over x can be written as this factor. I know one linear factor from root 1. What would be the factor? The variable is x, so x minus 1 is one factor, and then there will be another factor, right? And this one degree 3, so this factor must be degree 2, that's right. I'm going to have a degree 2 factor here. What is going to be that? Any idea what to do? How do I check my work? Multiplying, right? What is this process then, factoring? Just like dividing. Have you learned how to divide the polynomials? Yes. Would you like to use synthetic division or long division? Synthetic, good choice, because this divisor is linear, right? So let's do synthetic division. 1, -1, -6, and 6 from where? From these coefficients and constant, right? What number do I start with in the synthetic division? This is the divisor. Which number makes divisor 0? 1, that's right. So I'm going to put number 1 in the half of the box right there. Synthetic division. Bring down the number, multiply, and add top and bottom, multiply, add multiply, I did, and then add top and bottom, and multiply again. What do you expect for the remainder? If it is possible to factor, and remainder must be 0, right? As we expected, we have 0. Okay, we have 0. So what is the meaning of this number in the synthetic division? The last one is going to be the constant. Constant has degree 0, right? And one previous, that is going to be degree 1. And one before, that will be degree 2. So this is the coefficient number 1, invisible 1, with the x variable, degree 2, second power. Next one, 0 times x to the first power. Do I need to write 0 times whatever? No, I don't need to. So let's take the constant over here, and that's going to be a factor. Okay, make sense? So we use synthetic division to divide, and we found the divisor and the quotient, and divisor and quotient is a factor when we write a multiplication, okay? By the way, the question says use linear factors only, right? So I'm going to rewrite it as my linear factor. So I need to do one more time. Do you see difference of two squares? No? You don't see difference of two squares? Expand number system to irrational numbers, okay? Which two number makes 6 when you multiply? 2 times 3? Give me same numbers, not like that. 4 times what makes? No, don't use that numbers. Use irrational, crazy number. Which two numbers make 6 when you multiply? Square root of 6 times square root of 6. Square root of 6 to the second power is 6. So we'll factor using radicals, okay? So one factor will be x plus root 6. The other factor will be x minus root 6. That's how we find the linear factors, okay? We need to keep factoring until we have all in the linear. Does it make sense? Too much? You just use root, square root, okay? And then you can figure it out. So let's back to the graph, and that is number 1. And what would be the other number here then? Think about solving this equation. Zero product property. First factor can be 0, and we get 1. Second factor will be 0. Third factor will be 0. And what do we get from third factor? X will be positive square root of 6. So this is square root of 6, and this is negative square root of 6. Does it make sense? What is root 6 in the calculator? Let's see. What is square root of 6? Square root of 6, about 2.449. So our guessing number 2.5 was not actually not right, right? So we have to use exact number in math class. What's that exact number? Root 6, plus or minus root 6. So how many roots do we have now? We have 3 roots, right? Okay, so this is called irrational roots. And the first one is R-A-T, rat, rational root, okay? We have one rational root to number 1, and we have two irrational roots, root 6 and negative root 6. So in the future, in this lesson, in Unit 3, we'll talk about number of the solutions, type of the solutions. What kind of roots do we have? How many roots do we have? And we'll talk about theorems about the roots. Okay? All right. Any questions so far? All right. Let's move on to the next problem. Do you need more time to take notes? No? Okay. Move on. Next, what is the degree of this function?
4.
4. Correct. Degree. 4 polynomial function has 4 solutions. Okay. Do we have 4 solutions? Yes, we can see them, right? 1. Which one is exact? Right there, 1 and 2, right? So exact roots, that will be rational roots. How many rational roots? 2. What are they? Negative 2 and 1. And we may have 2 irrational roots, right? 2 irrational roots. Let's see if we can get those or not, okay? My pen. I can erase it. Oh, this is so stubborn. I can erase it. Oh, now it's gone. Irrational roots. We may have 2, and we'd like to find all of them, okay? So, let's see. Q of x can be written as factored form, right? All right, from the first root, negative 2, what is going to be a linear factor? X plus 2. From number 1, what is the linear factor? X minus 1. And this is degree 1, this is degree 1. So far, together, degree 2. What kind of a factor are we getting here? Degree 2 factor, right? How can I get this quotient if I use this as a divisor? So I need to do division, right? So let's do synthetic division one more time. All right. Okay, what is the first number I need to use? Invisible 1, right? Let me do it here. Invisible 1 and negative 1, negative 5, 3, 2. What number would you like to start with? 1 or negative 2? We'll use both of them, okay? Order does not matter, but which one would be easier? Positive number 1 would be easier. So I'm starting with the positive 1. So bring down this number. Wake up. You can stand up and study. Wake up. Bring down 1, and then let's multiply and add top and bottom numbers and multiply sideways and add, multiply. What do you expect for the remainder? 0, right? So let's see. We get 0 or not. Multiply and add top and bottom. Yes, that's a 0. What do I need to do next? What is the second root? I need to use one more time. So I'm going to continue using this result for the synthetic division. Okay, so you have a number like this, 12. Divide by 2 and continue divide by 3 like that, okay? So I'm dividing this polynomial function with 1 and then with negative 2 in the synthetic division. So we'll continue use this result, and let's do it one more time. So bring down number and multiply and add, multiply, add, multiply, and we get 0. So we do synthetic divisions twice, continuously, and then we'll get this quotient. So what would be the quotient from this result? X squared minus 2x minus 1, right? Is this a linear factor? No, this is a degree 1 factor, right? So I'd like to do one more time. How can I do that? So I need to think about doing x squared minus 2x minus 1 equals to 0. Can we solve this quadratic equations? Yes. How would you like to do the quadratic equations? Is it possible to factor? No, we figured it out. It's not possible to factor, right? So what would you like to do? Would you like to do complete the square technique or square both sides? All right, let's do one with quadratic formula. Okay, so my x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then we'll find two solutions. They are on the number line, okay? We have negative 2 and 1 here. They are rational roots, but we have other numbers here. Those can be found by doing solving equations, okay? All right, so A is 1, B is negative 2, C is negative 1, right? So let's plug the numbers. Negative of negative 2 plus or minus square root of negative b squared will be 4 minus 4ac. Two negatives make positive 4, and then all over 2a2. So let's simplify. What is the simplest form of root 8? 2 root 2. And now let's reduce. When we reduce, we do numbers with the rational parts. Don't do anything with this crazy number root 2, okay? So we keep it. So that there is invisible 1 in front of root 2. So that is 1 plus or minus root 2. So if I rewrite this in the factored form, and everything must be in the linear, and I'm going to write this way. X plus 2, 1 factor. X minus 1, another 1 factor. And then let me put bigger parentheses like that. X minus, and one solution is 1 plus root 2. So I'm going to put 1 plus root 2 in the parentheses. 1 minus root 2 in the parentheses, okay? Would you like to expand those parentheses? And then yes, you can do that. And x plus 2, x minus 2, 2 factors. And next one, you will distribute this negative to get rid of this inner parenthesis. So you can have x minus 1 minus root 2 as one linear factor. And the other can be x minus 1 plus root 2 as another linear factor. And those are the solutions, okay? So I can use 1 plus root 2 as one solution, 1 minus root 2 as another solution, and we have 4 real solutions on the graph. So higher one must be with plus 1, right? That is 1 plus root 2. And the small one on the left would be with negative sign, so that is 1 minus root 2. Root 2 is about 2.14. No, I'm sorry. Root 2 is about 1.414. So you add 1 on it, 1 plus, and that will be 2.4 something something, okay? So that is about 2.4 at that point. Does it make sense? So in number 12, we did the same process. And we know exact number on it. And then we are using that as a linear factor. And we try to find the blank, that is the quotient from the division. So we did synthetic division continuously to get the quotient. After that, we know how to solve quadratics OR, so we use the quadratic formula to find this. Okay, so this is a little tough. If I choose a question for the quiz from number 9, 10, 11, 12, which one would be the best problem for the quiz to test my students' understanding? Number 11 would be the best one. I don't want you to struggle on number 12 like that, okay? Number 11, I can ask, you know how to use synthetic division and linear factors. So number 11 would be a good question. All right, this is the lesson for today, and keep watching if you don't get it, and study with the same problems.